Welcome to Spaceverse, your portal to cosmic adventures. Webb's infrared vision has unveiled what was once hidden, revealing a breathtaking celestial phenomenon. Amidst chaotic swirls of dust, a glowing marvel is emerging, one that could endure for millions or even billions of years. The James Webb Space Telescope has captured the rare and remarkable moment of a star's birth, providing us with a live view of this cosmic event occurring within a dense gas and dust cloud, approximately 450 light-years away in the Taurus constellation. At the heart of this dark cloud lies Herbig-Haro Object 30, showcasing a young star encased in a protoplanetary disk. Witnessing age 30's formation in such sharp detail is yet another testament to Webb's groundbreaking capabilities. This revolutionary telescope continues to deliver some of the most awe-inspiring images of space, allowing us, for the first time, to observe the intricate processes within the dark cloud LDN 1551 in unprecedented clarity, thanks to its advanced infrared technology. Unlike Hubble, Webb detects infrared wavelengths, which can penetrate cosmic dust in dense clouds like LDN 1551. This allows astronomers to peer directly into these stellar nurseries, offering an almost first-hand view of star formation. Dense clouds of gas and dust serve as the birthplaces of many stars across the universe, including our own Sun, which originated from condensed dust. Through a fascinating interplay of gas, dust, and motion, new stars gradually take shape within these dense regions. Scientists classify the glowing formations surrounding young stars as Herbig-Haro objects, created when stellar jets collide with surrounding material. These jets, moving at hundreds of kilometers per second, produce intense radiation and heat alongside the infrared emissions that Webb so brilliantly captures. Age 30 reveals two powerful jets bursting into space from deep within the protostar. While Hubble previously observed this star-forming region, the dense nebula obscured much of the internal activity. Now, Webb's sharper and more detailed images unveil previously hidden aspects of the process, providing scientists with invaluable new insights into how stars are born. In the latest image released by NASA, we can see the protoplanetary disk, a stream of ejected gas and dust, and a narrow jet emerging from the cloud. The birth of a star is a gradual event, taking tens to hundreds of thousands of years. Long after the star has formed, the leftover gas and dust eventually coalesce into planets, just as our solar system did 4.5 billion years ago. The structures known as Herbig-Haro objects, shaped by the activity of stellar jets, typically evolve over several millennia, making them some of the most fascinating phenomena in the universe. Age 30 has been affectionately nicknamed the Hungry Baby because of its rapid growth. Looking at these images, one might wonder, are baby stars like human infants? Do they have parents in a cosmic sense? Even the most rational scientists sometimes find themselves making such comparisons. Like a newborn, age 30 is constantly growing, voraciously consuming vast amounts of gas and dust from its surroundings. Except instead of milk, this young star feeds on the very building blocks of the universe. The birth of a star is a grand cosmic event that unfolds over hundreds of thousands of years. It begins within a dense cloud of gas and dust, where a disturbance, such as a nearby supernova explosion or the collision of gas clouds, triggers the collapse of material. Gravity then takes control, pulling the gas inward, causing it to heat up and spin faster. However, not all the material falls directly onto the forming protostar. Some of it spreads out into a flat, rotating disk around it. This protoplanetary disk serves as the birthplace of future planets, though they must make do with whatever the growing star doesn't consume. In some cases, the young star may even engulf a developing planet. Much like a newborn struggling to drink too quickly, a forming protostar cannot immediately absorb all the material falling onto it. As vast amounts of gas and dust spiral inward under the force of gravity, the young star's developing core becomes overwhelmed. Unable to process the inflow all at once, the excess material is forcefully expelled along its rotational axis in the form of powerful, high-speed jets. These streams of gas, traveling at staggering speeds of up to 700,000 kilometers/age, pierce through the surrounding nebula, carving through space like celestial fire hoses. When these jets collide with the surrounding interstellar medium, they generate intense shock waves that energize and illuminate the entire region, creating a breathtaking cosmic light show. The result is a dynamic, ever-changing spectacle, one of the most mesmerizing and visually striking phenomena in the early life of a star. As time progresses, the once chaotic protostar undergoes a remarkable transformation, gradually stabilizing as it nears the final stages of its formation. The relentless inflow of material slows, and the violent jets that once blasted into space begin to weaken and dissipate. Deep within its core, temperatures and pressures continue to rise until they reach a critical threshold, millions of degrees hotter than the surface of the Sun. At this point, a monumental event occurs. Nuclear fusion ignites, and the young star begins converting hydrogen into helium. This process releases an immense amount of energy, generating the outward radiation pressure needed to counteract the force of gravity trying to collapse it further. With this delicate balance achieved, the star officially enters the main sequence, marking its transition into full maturity. The turbulent early years fade into memory, replaced by a steady, radiant glow that will endure for millions or even billions of years. What remains is a brilliant new celestial body, one that will illuminate its surroundings, potentially host planets, and contribute to the grand cosmic dance of the universe. This marks the beginning of planetary formation. Now that the star has reached a more stable phase, planets can develop without as much disruption. They slowly take shape, gathering leftover material from the protoplanetary disk, orbiting the star that will provide them with warmth and light for billions of years. Age 30, mysterious spiral patterns unveil astonishing discoveries. While observing the young star age 30, the James Webb Space Telescope detected an intriguing feature: spiral structures within its protoplanetary disk. These spirals are more than just visually striking, they may hold vital clues about planetary formation and the forces shaping a star system in its infancy. Scientists at the University of Tokyo, led by Dr. Ryotazaki, have proposed 3 possible explanations for these mysterious patterns. One possibility is that the spirals are caused by a wobbling jet. Protostars like age 30 eject material into space in the form of 2 opposing jets, and if these jets fluctuate or shift slightly, they could disturb the surrounding gas and create the observed spirals. Another explanation suggests the presence of a hidden companion star. Some stars are born in pairs or as part of a multiple star system, and if age 30 has an unseen stellar companion, its gravitational influence could be distorting the dust disk, much like how the moon's gravity affects Earth's tides. A third theory proposes that a passing star may have been responsible for these patterns. Around 1,000 years ago, a nearby star could have moved close to age 30, exerting gravitational forces that left behind long-lasting disturbances in the disk, now visible as spirals. Such encounters are not uncommon in the densely packed star-forming region of the Taurus constellation. These spiral structures are more than just a curiosity, they could be a crucial element in understanding how planets form. The way they shape the movement of gas and dust within the disk may lead to the development of planetesimals, the foundational building blocks of planets. By studying these patterns, astronomers hope to gain deeper insights into the processes that eventually give rise to entire planetary systems, including ones like our own. Similar spiral structures have been observed around other young stars, indicating that this phenomenon is widespread in star-forming regions. With the James Webb Space Telescope, scientists may be uncovering the very blueprint of planetary formation, and perhaps even the blueprint of the universe itself. Webb offers a crucial key to understanding the origins of the cosmos. Since its mission began, the telescope's golden eye has provided groundbreaking insights into the universe's formation, far beyond individual star births. Its observations reveal the oldest galaxies, challenge established scientific models, and capture stellar nurseries like age 30 in stunning detail. These discoveries allow us to peer into the deepest mysteries of the universe, shedding light on the processes that shape not only our solar system, but the cosmos as a whole. By studying young stars like age 30, astronomers gain a clearer picture of the fundamental forces responsible for creating galaxies, planetary systems, and the intricate structures we see today. Despite the universe's vast complexity, A few simple physical principles may govern its expansion, continuously bringing order to chaos and generating the breathtaking celestial formations we observe. Every spiral in a protoplanetary disk, every jet of ejected material, and every swirling cloud of gas and dust carries the story of cosmic evolution. Scientists have long sought to piece together this narrative, one of gravity, matter, and the transformation of disorder into structure. The same principles that shape a single star-forming region like JWST once governed the birth of the first galaxies. The James Webb Space Telescope was initially designed to peer deep into the universe's past, capturing the faint light of the very first galaxies that formed when the cosmos was still in its infancy. Scientists expected to find primitive, chaotic structures, young galaxies still assembling themselves in the wake of the Big Bang. However, Webb's breathtakingly detailed images delivered an astonishing revelation. Many of these early galaxies appear far more developed and massive than previously thought, displaying structures and characteristics that should have taken much longer to form. These surprising findings challenge existing cosmological models, which predicted that the first galaxies would be small, irregular, and slowly evolving. Instead, the presence of mature galaxies so soon after the universe's birth has sent shockwaves through the scientific community, forcing astronomers to reconsider fundamental assumptions about cosmic evolution. The discoveries suggest that galaxy formation may have progressed at an unexpectedly rapid pace, hinting at gaps in our current theories about dark matter, the expansion of the universe, and the physics governing the early cosmos. As researchers scramble to refine their models, Webb continues to reshape our understanding of the universe's origins, proving that even our most advanced theories may only be part of a much larger, more complex story. When the universe burst into existence with the Big Bang 13.8 billion years ago, it was an unimaginably hot and dense sea of energy, where particles constantly collided and annihilated in a chaotic frenzy. In the first fractions of a second, fundamental forces separated, and matter began to take shape. As the universe expanded and cooled, atomic nuclei formed in a process known as nucleosynthesis, setting the stage for the creation of the first atoms. Over the next 100,000 years, tiny quantum fluctuations, imperceptible variations in density, were stretched across vast cosmic scales by inflation, providing the seeds for future galaxies. Under the relentless pull of gravity, these denser regions gradually gathered more matter, forming immense clouds of primordial gas primarily composed of hydrogen and helium. As millions of years passed, these gas clouds continued to collapse, their internal pressure and temperature rising until nuclear fusion ignited the very first stars, marking the beginning of a new era in cosmic history. These stars, far more massive and short-lived than those we see today, illuminated the darkness and forged heavier elements that would later give rise to planets, moons, and even life. The enigmatic spirals in JWST's protoplanetary disk, revealed by the James Webb Space Telescope, may serve as a model for the formation of much larger cosmic structures. Spiral patterns are fundamental to the universe's design. They appear everywhere, from the arms of the Milky Way to the massive filaments of galaxies stretching across the cosmos. These mesmerizing spirals emerge in regions where matter accumulates, where vast streams of gas coalesce into structured patterns, and where gravity orchestrates the grand celestial dance. From the swirling arms of spiral galaxies to the accretion disks around newborn stars, these formations appear across vastly different scales, hinting at a profound underlying order in the cosmos. What makes this phenomenon even more fascinating is that the very same fundamental forces shaping individual stars and planetary systems may also be responsible for sculpting entire galaxies. The interplay of gravity, angular momentum, and fluid dynamics governs both the birth of stars within nebulae and the majestic spirals of galaxies spanning hundreds of thousands of light years. By closely studying these smaller, more accessible processes, such as the rotation of protoplanetary disks or the behavior of gas clouds collapsing under gravity, scientists can uncover insights that apply to much larger cosmic structures. This approach allows researchers to bridge the gap between the micro and macro scales of the universe, revealing a deeper, interconnected framework that dictates how matter organizes itself across space and time. As our understanding of these intricate patterns grows, so too does our ability to decode the hidden laws shaping the vast cosmic architecture. But the significance of these discoveries goes beyond star and galaxy formation. They may also provide insight into the origins of life itself. Stars like Age 30 do more than generate energy. They serve as cosmic forges where the elements essential for planets, oceans, and living organisms are created. Within their fiery cores, nuclear fusion produces the heavy elements that eventually give rise to worlds like our own. In fact, every carbon atom in our bodies was once formed in the heart of a long-extinct star, highlighting the profound connection between the life we know and the vast processes that have shaped the universe. The James Webb Space Telescope's observations not only reveal the past of our solar system, but also offer a window into the grand cosmic symphony of creation, an ongoing process that began billions of years ago and still unfolds today. With its golden mirrors scanning the universe each day, Webb continues to unveil new discoveries, bringing us ever closer to understanding our origins. And that's it. Thanks for exploring the cosmos with Spaceverse. Webb's discoveries reveal the secrets of star birth, galaxies, and our universe. Subscribe now, our journey has just begun.